welcome to another lesson. I believe you are fine. Please enjoy the lesson. We have looked at capacitors, what a capacitor is, what capacitance is, what a dielectric is, then different calculations, then arrangement of capacitors, the effective capacitance, and so many things about capacitors. And if truth is to go by, we are almost coming to the end of this topic, meaning you are already keeping the 20% of what you need to get that A in the physics paper 2. Please keep that 20, because it is only in this chapter of capacitors that the 20 is available, as long as you have teacher course of Back Science Education Consultants. Don't go away. Remain here on this channel. So today we want to look at comparing the capacitances. Now you have two capacitors. You are presented with two of them, and then you don't know which capacitance do they have, or which one has a greater capacitance than the other one. So how do you compare the capacitances? We have two sets of apparatus that we are going to use. So the first one is we are using a vibrating reed switch circuit. Remember this circuit? We started with it. We have been using these circuits to perform very many practicals. Now we are still using it. So how do we compare? We have two capacitors. Okay? So one will be of capacitance C1, another will be of capacitance, let's say C2. We want to compare them. Which one has a greater capacitance than the other? But as I told you, there is no device that is used to measure the capacitance. I want you to get that. At this level, we are not going to have any device that we are using to measure the capacitance. We shall use other several devices to measure other things. For example, the current, the deflection, and etc. And then we compare, or we perform the calculations. We do the computations. So for this case, what are you going to do? It is as simple as we are going to insert this capacitance, let's say of the capacitance, the capacitor of capacitance C1 in this circuit. Then we are going to activate the reed switch circuit at a suitable frequency. We call it F. What happens? This switch K, this reed switch, will make contacts at X and Y, as we saw in the previous practicals or in the previous experiment. So it will make contacts at X and Y, thereby charging and discharging this capacitor respectively. When it makes contact here, it charges it. When it makes contacts at Y, it discharges it. And when it discharges, this is a galvanometer. This galvanometer will be recording the current I that is passing through this, which is as a result of this capacitor being discharged. Are we together? So therefore, after charging this capacitor and discharging it, we shall record a certain current through the galvanometer. That current, maybe we call it I1. So when we have a capacitor of capacitance C1, we shall record a current I1. What do? We switch off. We remove the capacitor. We replace with another one of another capacitance C2. So therefore, when we insert there a capacitor of capacitance C2, we do the same. Activate this one. It makes contact at X and Y, and then it is discharged through this, and then you record another current I2. Okay? So with capacitor of capacitance C2, we get current I2. Then, how do we compare the two? The comparison is as simple as we just say the capacitance 1 out of the capacitance 2 is I1 out of I2. Then, depending on the size of this, then you can know which of these two is bigger than the other. Is that one easy? Yes, it is as simple as that. Are you there? How do we arrive at that? What is capacitance? If we have a capacitor of capacitance C1 here, we know that capacitance is 2Z. Yes, is 2V. Or wait, not capacitance, what? The current. We know that the current is the rate of flow of charge. Okay? Q over time, which will become QF since we have the frequency. But the charge is CV. So we shall say that I is CVF. Meaning that the I1, when we have a capacitor of capacitance C1, will be this. The voltage and the frequency are not changed, so they remain the same. You can say that is the first equation. When you put a capacitor of capacitance C2, you get an I and I2, which is C2VF. That is equation 2. And you realize that if I get equation 1 and divide by equation 2, I'm able to get I1 out of I2 equals C1 out of C2. And therefore, that's how I said I1 out of I2 equals C1 out of C2. So by so doing, we are able to compare and know which capacitor has a greater capacitance than the other. Look, what if you now need to know now the capacitance of one of the capacitors? What do? We use a standard capacitor. So for example, if this one is standard, it is known, a capacitor whose capacitance is known is what we call a standard capacitor. Anything that you hear in science and somebody say a standard resistor, a standard whatever, you just know that that quantity is known, okay? Is known. So a standard capacitor, a capacitor whose capacitance is known. A standard resistor, a resistor whose resistance is known. A standard inductor, an inductor whose inductance is known, okay? Is known. So therefore, if let's say this one is known, and we know this is 10 microfarads, so we can be able to determine this. Because we have maybe known this one as maybe 2 amps, and maybe this as 5 amps. So by saying C1 is I1 out of I2 then times C2, we can substitute for all of those ones, and since we have them, then we can get C1. So therefore, you will be expected to answer questions like, describe how the capacitance of a capacitor is determined using a known capacitor or using a standard capacitor. So you know this, you don't know the other one, so you perform this one. That is when you are using a vibrating reed switch circuit. I know you want to write something down so that you can have a point of remembrance. You can have a point of remembrance. So what did I say? Of course, you begin by drawing the diagram, okay? And for our case as Uganda, that one will be taking some good marks when you describe the whole of it. Can be 6 marks or 5 or yeah, around there. So you have to get it so that you capture all those marks because it is very easy to handle. Okay? So you can say that a capacitor of capacitance C1 is connected in the circuit as shown. A reed switch K is activated at a suitable frequency F. The capacitor is continuously charged and discharged by the switch K making contacts at X and Y respectively. The capacitor is continuously charged and discharged by the switch K making contacts at X, that is charged, and Y, that's discharged, by making contacts at X and Y respectively. The constant current I recorded by the galvanometer is noted. The constant current I1 recorded by the galvanometer is noted. The capacitor of capacitance C1 is disconnected from the circuit and replaced with capacitor of capacitance C2. The reed switch circuit is then activated at the same frequency and the procedure repeated. And the same procedure repeated. The reading of the galvanometer I2 is noted. The reading of the galvanometer I2 is noted, and the capacitors of capacitances C1 and C2 are compared using the expression, C1 out of C2 equals I1 out of I2. C1 out of C2 equals I1 out of I2. Note, in case C2 is known, then C1 can be determined. In case C2 is known, then C1 can be determined. Okay? So how do you determine that? So you can say experiment. Yeah, we are doing that. Experiment to determine the capacitance of a capacitor using a standard capacitor. Experiment to determine the capacitance of a capacitor using a standard capacitor. That one I shall call it CS, that is standard. Okay? So what do? You tell me that, of course you first do that, okay? And you want to know the C1, okay? So you tell me that the reed switch is activated at a suitable and constant frequency F. The switch K makes contacts at X and Y respectively. The capacitor C1 is charged and discharged through the galvanometer. The galvanometer reading I1 is noted. The capacitor C1 is replaced with the capacitor CS, this one. The same procedure is repeated. The current recorded by galvanometer I2 is noted. The unknown capacitance C1 equals I1 out of I2, then C2. By doing so, you have described that. That is perfect. That's the beauty of science. Science without cramming is perfect. Science without cramming is perfect. Guess what? Science with cram work is hell. Don't try it at home. We want to do the same experiment using a ballistic galvanometer. We want to do this same experiment using a ballistic galvanometer, and this one is now part B. So comparing capacitances using a ballistic galvanometer. So this is now the second one, using a ballistic galvanometer. So you can have the DC supply, and then we have this capacitor, okay, then shall have some switch there, then this is our ballistic galvanometer, then shall have some other switch. You can call this one K1 and this one K2. This is a DC supply, this is a capacitor. Okay? Maybe you begin with the one of capacitance C1. So what do? Our intention is to charge and discharge. So what happens, for example, if you close this switch when this one is open? When you close here, this circuit is complete, meaning this supply will charge the capacitor. What happens if you open here and close here? This one will be discharged. Okay? Therefore, what do? We charge and discharge this capacitor by closing switch 1 when K is open, and then opening switch 1 and closing switch K2. So what happens? When you close switch K1 and open this is charged. When you close this and open this is discharged. When the capacitor is being discharged, we shall see a deflection from this ballistic galvanometer. Maybe that is theta 1. When we have our capacitor or capacitance C1, guess what do we do? Actually, tell me, what do you think we do after that? Yes, we replace this capacitor of capacitance C1 with the capacitor of capacitance C2. So therefore, this one will be replaced with the capacitor of capacitance C2. And you do the same. You again close this, meaning it will be charged. Then open this and close this, it will be discharged. So you also see another deflection. When you have C2, you have a deflection theta 2. Okay? So how do you compare? You just say that capacitor C1 over that of C2 is theta 1 out of theta 2. And by so doing, you can be able to compare and see which one is bigger than the other, right? And in any case, if one of the two is known, is standard, then you shall be able to determine the other one. Because this can be 2 degrees, 4 degrees, 6 microfarads. So therefore you can be able to get that, right? So that's what you do using a ballistic galvanometer. How do we get that? How do we get that? Okay, we get that one by following the charge. The charge acquired by this source will be now as it is passing through this. So we know charge is CV, but that charge is proportional to what? To the deflection. When charge is big, the deflection is big. When it is small, the deflection is small. Meaning, if the first charge C1V, which is K theta 1, then the second one C2V equals K theta 2. So when you get this divided by this is the same V because it's the same DC supply. So shall have C1 out of C2. The K will cancel. Shall have theta 1 out of theta 2. You can see the beauty of physics. Don't go away. Remain at the back. Science education consultants, where understanding. If we don't take it as breakfast, then we take lunch as early as possible. That is understanding. And then the continuity of learning amidst all challenges is ensured. Because even if you wake up when the teacher is not there, just go on YouTube and say back science. You get the lesson and study and answer the question. Send on my WhatsApp. In the morning I find your answers. I mark you and correct you. You get A and achieve what you want academically as we congratulate each other. Therefore, we are saying that the capacitor of capacitance C1 is first charged by opening switch K2 and closing K1. It is then discharged through the ballistic galvanometer by opening switch K1 and closing switch K2. The first deflection theta 1 of the ballistic galvanometer is measured and recorded. The capacitor of capacitance C1 is disconnected and replaced with the capacitor of capacitance C2. The procedure above is repeated and the deflection of the ballistic galvanometer recorded as theta 2. The capacitances of capacitors C1 and C2 are compared using this one. Are compared using C1 out of C2 equals theta 1 out of theta 2. How do you obtain that? It is very simple. So you can write a note. Note. You can write a note that initial charge stored when we have a capacitor of capacitance C1, Q1 equals C1V, which is K theta 1. Equation 1. Okay? And also, when you have the capacitance C2, the charge stored Q2 is C2V, which is K theta 2. So if you get this divided by this, is this divided by that. So if you have 1 divided by 2, it will give you theta 1. C1 out of C2 equals theta 1 out of theta 2. So that's how we are able to get that expression. Meaning, if I have also one of these capacitors known, maybe this or that, then I can get the other. You are going to do this question. Describe how the capacitance of a capacitor is determined using a battery, 2 switches, a ballistic galvanometer, and a standard capacitor of an unknown capacitance. What did I say? That describe how the capacitance of a capacitor is determined by using a battery, 2 switches, a ballistic galvanometer, and a standard capacitor. That is a capacitor with known capacitance. So the way we did in the other first case, you can also use the same when you decide to make one of them a standard one, and then you can be able to describe that. My friend, congratulations. We have been able to come to the end of the chapter. Congratulations. Now, we shall not stop there. We need now more questions for practice. I'm going to handle them. But as for the case of the chapter, we have studied almost everything. So now we are remaining with do more questions together as we practice, as we apply the knowledge of what we have studied. We get experience, get exposed. And that one happens if you start working out all the UNEB questions in this chapter. You are going to be there. Otherwise, thank you very much for attending our lessons. Be blessed.